Hello, everyone. Welcome to this course on the standard EN 5126 by ramsrail.com. This course is part of a series of courses explaining how to manage RAMS in the railway sector. The main goal of this course is to learn what is the scope of the standard, the relationship with other standards of the same family. If we go back to the previous example and we throw some numbers to illustrate, for instance, 48 hours for the system to be restored after each failure and a total operation time of 5,000 hours. We can see that the formula is straightforward and gives us a system availability of 98%. The lesson learned here is, if the MTTR grows, the system availability will be reduced. A new software standard 5716, released in the end of 2023, merges and replaces the two standards we just saw. The new standard is better aligned with 5126. Readability has been improved and additional guidance added. The old software standards can still be used until October 2026. After that date, the new standard will be the only one defining the software development process for railway applications. Time to test your knowledge. Let's do a simple exercise. In this slide, you can see 5 different scenarios. Leaving aside any potential legal and contractual framework, which RAMS standards do you think we should apply in each of them? Let's see an example of how a mission profile will impact safety calculations in future phases. On the left part of your screen, you can see the photograph of a master controller. This master controller is used to drive the trains. It has different levers and switches. In this example, let's focus on the first of them, on the top left, which is also known as the direction controller. The standard 5126 contains a series of tables in Annex C, suggesting the following discrete categories for the classification of the frequency. These 6 categories range from frequent, for hazards occurring more than once every 6 weeks, until highly improbable, for hazards occurring once in 100,000 years or more. Random failure integrity is that part of the safety integrity which relates to hazardous hardware random faults. They are related to the finite reliability of hardware. Random failure integrity has to be demonstrated by a quantified assessment. This means by probabilistic calculations. This is typically done using the fault tree analysis technique. In special cases, complex systems may also be modeled using Markov chains, Monte Carlo methods, Petri nets, etc. It is important to highlight at this point that to demonstrate the integrity of our system, it is necessary to satisfy both the systematic and the random failure integrity requirements. It is useless to end up with a system with a really small random dangerous failure rate if later we have not followed any of the techniques and measures to protect the system against systematic faults. A second example of THR apportionment could be the following. Let's imagine we have a level crossing which is protected by 2 fully independent functions. The first function is named lights and acoustic alert. The second function is named lower the mechanical barrier. If our top event is unprotected level crossing, and we assume human influence, all humans are subject to occasional lapses in performance. When they occur in earlier phases of the life cycle, they can result in systematic failures in the operational phase. When these occur in the operational and maintenance phases of the system life cycle, they could also result in random failures. Please pay attention when you apportion a THR to a function and a human. Do not overestimate humans. Do not use the SIL concept for humans, neither for mechanical parts of the system. Risks related to mechanical parts of the system will typically be managed via codes of practice. The terms verification and validation are often confused by people new in the RAMS domain. This slide tries to summarize once again the difference. Verification is done at every step. It checks if we are building our product right. On the contrary, validation checks if we are building the right thing, focusing on initial requirements from customer and system level and ensuring they are satisfied at the end of the software cycle. Let's consider a function that calculates the speed of a train. It takes 2 inputs, distance and time, highlighted in orange in this slide. One of the principles of defensive programming is to ensure that the software inputs are valid before performing any operation with them. In this example, we have created a couple of checks to ensure the distance and time are not negative. If this occurs, the software will show an error instead of displaying a negative speed. This simple example illustrates the philosophy of defensive programming, consisting of: once the software components have been individually tested, it is time to start connecting them together. This phase is called integration. In this slide, we introduce different types of performance testing. Let's see them. Load testing checks the software's ability to perform under anticipated user loads. The objective is to identify performance bottlenecks. Stress testing involves testing a software under extreme workloads to see how it handles high traffic or data processing. The objective is to identify the breaking point of an application. Endurance testing. A common cause failure occurs when one event or shared factor causes two or more failures. Because they have one and the same cause, the failures are not statistically independent. This is contrary to the core assumption of usual reliability theory that all failures are independent and uncorrelated. A simple example is shown here, where a function is implemented by two channels. These two channels share the same power supply as source. This means that whenever a failure in the power supply occurs, both channels will fail simultaneously. The CSMs are established in accordance with Article 6 of Directive 2016/798, also known as the Safety Directive. It is important to highlight here that there are up to 7 common safety methods, each of them having different purpose. The most famous one at the industry is the Common Safety Method for Risk Evaluation and Assessment, also known as CSMRA. Before we dig into this one, let's quickly say a few words about the other 6. Is Regulation 402/2013 mandatory? Depends on your country. In the European Union, all EU regulations are mandatory. The CSMs are directly applicable and enforceable in the member states. Depending on the scope of the change, they are applied either by authorities or bodies, or by specific actors of the railway system, for example, railway undertakings, infrastructure managers, entities in charge of maintenance, or even by both. How many versions of CSMRA exist? The first version of CSMRA was published in 2009. It is now obsolete in the EU. The second version of CSMRA was published in 2013 and is the current version applied in the EU countries. This new version superseded completely the 2009 version. One of the main change against the older version is the definition of strict requirements for an entity to become an ASBO. ASBO stands for Assessment Body and is an independent entity that will make sure that the proposer is applying the CSMRA correctly and that the results are satisfactory. Once a change has been classified as significant, the next step is to prepare an accurate system definition. The system definition shall address at least the following issues: system objective. This means what is the intended purpose. System functions and elements including human, technical, and operational elements. System boundary including. Continuing with the CSMRA process, it's time to select the risk acceptance principle. Please remember that we have already identified all hazards in previous steps and filtered out those whose risk is broadly acceptable. For the rest of hazards whose risk cannot be considered as broadly acceptable, a risk acceptance principle shall be chosen. The risk acceptance principle is basically the strategy we will follow to reduce the risk associated to each hazard. Ready to elevate your engineering skills? Unlock the full course now and gain expert knowledge, practical insights, and exclusive content. Don't miss out. Enroll today and take the next step in your professional journey.